When we look at this problem, we're going to see that it is quite obviously a momentum problem. We have a few things to note. We have identical carts. There is no friction. We have a specific time given to us. Our first cart is moving, and it collides with and sticks to another cart, which means we have an inelastic collision. That other cart is initially at rest, which means that it is not going to have any beginning momentum, and we are looking for the graph that fits this best. So it should be fairly obvious that A is not the answer, because we should know that if you have one object hitting another that is at rest, that the velocity is going to change. Similarly, we should be able to reason that while the carts will slow down and no longer be traveling 2 meters per second, their momentum and their velocity will not go down to zero. So we can rule out D. We're left between B and C, which means we need to calculate the final velocity of these carts after the collision. So we can set a conservation of momentum equation up. We have our initial momentum, which is only going to be cart X. By the way, since they're identical, we can go ahead and just label one mass for both of them. We have our velocity of X. Since we know that there is no momentum for cart Y, we don't even have to put a term in, although if you want, we can put mvy, and then we can cross that out because we know it's zero. Equals, and our final object is going to have a mass equal to both of them combined because they're stuck together, and it's going to have a final velocity. What we are solving for is this final velocity right here. So all we need to do is basically divide by m plus m, which should be fairly easy to do. Keep in mind m plus m is going to equal 2m. When we divide both sides, what we're going to find, that cancels. And the cool thing is our m's cancel out. So we find this is actually independent of mass. Makes the math a little easier. So we're left with v prime, or our final velocity, equals our initial velocity, which is our vx, over 2. When we plug in that value, it's going to equal 2 meters per second over 2, which is 1 meter per second. We look at the graph that at time t1 goes down to 1 meter per second, and that is C. If we look at the answer key, we see that that is correct. We are basically doing a fairly simple conservation of momentum problem.